Assalamu alaikum, dear students. Welcome to our next class. In this lecture, we are going to discuss the continuity of function f of x is equal to x raised power n. It's actually a question from your exercise number 5.1. It's question number 4. So we have to prove that the function f of x is equal to x raised power n is continuous at x is equal to n, where n is a positive integer. So we have to prove that x raised power n is continuous. So for that, what we have to do, we know the definition of continuity, that whenever the limit exists, it should be equal to f of c. That means a limiting value extending to c, f of x is equal to f of c. Okay, so here we should have limiting value extending to n, f of x is equal to f of n. For that, what we will do, we have the function f of x is equal to x raised power n. Now, at this, we want to find the limiting value. So, limiting value as extending to n, f of n is equal to limiting value extending to n, x raised power n. So it is x raised power n, and since n is positive integer, we can put it here. X tending to n means it's x raised power n, means it's n raised power n. So its limiting value extending to n, f of x is equal to f of n. So by the definition of continuity of function, we can prove that. We proved it like you can see here. If we have the definition of continuity, so uh, it fits in accordance with the definition of continuity, limiting value extending to n, f of x is equal to f of n. So we can conclude that this given function is continuous for all positive integers. So next we have question number 5. It's actually a step function, and in this function we have two branches. Its uh, function is defined separately for x less than or equal to 1, and it is defined separately for x greater than 1. So for x less than 1, it is defined like this. Uh, it is f of x is equal to x raised power, f of x is equal to x for x less than or equal to 1, and for x greater than 1, it is defined as pi. It's a fixed value. So the question says we have to check the continuity. Question number 5, we have to check the continuity at x is equal to 0, at x is equal to 1, and x is equal to 2. So for x is equal to 0, we have to go in the left branch, that is x less than or equal to 1. We have to check the continuity in this, f of x is equal to x. So for x is equal to 0, the function is defined, f of x is equal to x. Okay, so we will check it here. We will write it here. Function is like this. At x is equal to 0, limiting value we will find, that's equal to limiting value extending to 0 x. So if we'll put this x is equal to 0, it will be 0. So limiting value extending to 0, f of x is equal to f of 0. So we can say by the definition of continuity that the function is continuous at x is equal to 0. Okay, at x is equal to 1, what we have to do? At x is equal to 1, we have two branches. On the left, it is defined as x, and on the right, it is defined as pi. So if we try to find the left-hand limit or the limiting value or the functional value, we have to find that from the left part, that is f of x is equal to x. So limiting value extending to 1 negative is equal to limiting value extending to 1 negative x, that's equal to 1, because left hand limit is to be calculated from this part, from f of x is equal to x, so it is equal to 1. And the right hand limit, if you want to calculate, that's to be calculated from the right hand part, that is x greater than 1. And at that point, f of x is defined as 5. So we have to write it like this: a right hand limit, limiting value extending to 1 positive, f of x is equal to limiting value extending to 1 positive, and instead of f of x we have 5, because f of x is defined as pi, so this is equal to 5. So you can see here that left hand limit that was calculated as 1, and right hand limit that is calculated as pi, they're not equal, and hence left hand limit is not equal to right hand limit. We conclude that the function is not continuous at x is equal to 1. At x is equal to 2, we see the function is defined for x is equal to 2 as pi. So the definition of the function is here, f of x For x greater than 1 is 5. X greater than 1, it is 5. That means for all values above 1, f of x is defined as 5. So we will find the limit at x is equal to 2. Here, limiting value extending to 2, f of x is equal to limiting value extending to 2, f of x instead of f of x, we have to write 5. So this is equal to 5. And functional value at x is equal to 2 is also 5. So that is equal to f of 2. Hence, limiting value is equal to functional value. We conclude that function is continuous at x is equal to 2. Similarly, we have this next function. Here we are supposed to calculate the points of discontinuity of this function. First of all, I would like to tell you here that if f of x is a polynomial function defined in branches, then it is continuous in either of the branches. But at those points where the branches are defined, for example, here we have x less than or equal to 2, x greater than 2. At these points, we have to check whether the function is continuous or not. So at all other points, it is continuous. It's polynomial function, it is continuous. So at x is equal to 2, we have to find the left-hand limit. If we will find the left-hand limit is to be calculated from 2x plus 3, and right-hand limit is to be calculated from 2x minus 3. If we will calculate the left-hand limit from 2x plus 3, we have like this. You can see it here. Left hand limit is equal to calculated from 2x minus 3. So it's 2c minus 3, and right hand limit 2c plus 3. So they are not equal. Okay, so we can say that these two values are not equal because this is calculated as 7 and this is calculated as 1. So they are totally different. 7 is not equal to 1. Hence, we say that the function is not continuous at x is equal to 2. So 2 is the only point of discontinuity of this function. On the same lines, you can see other questions of this exercise. Okay, so for other questions, you can follow the definition and solve all these questions. Hope you can do all these questions. If you have any problem in solving these questions, you are welcome to ask these questions in the comment section of the video, or in the group of class 12 that is governed by our school. Thank you for joining the class. Thank you once again.